Question: do you like to play computer games? How about making them? Today, we're going to meet some engineers from IBM in Atlanta who are creating a fun, educational 3D game all about kinetic energy, wind turbines, and the environment. We brought in 3 kids who are going to design their own wind turbine, build a scale model, and then create a computerized 3D virtual version of it. Think they're up to the challenge? Well, they think they are. Come along with us as we discover engineering.
Hello there, welcome. My name is Kim. Are you ready to have some fun?
Yeah.
Do you like playing computer games?
Meet Kim Cook-Boyd. She leads a team that develops educational 3D games for IBM. Their latest game is all about the power of the wind.
Do any of you know how computer games are made or developed?
Not a clue.
No?
I do know a lot about computer games, and because I play them a lot when I'm at home, but I don't know that much at all on how they're made.
I think that computer games are probably made on the computer, and that it involves a lot of clicking.
I think they're probably made for some computer graphics or something. I don't know.
Well, at least they're honest. No worries. Kim and her team will show them what they need to know.
Engineers like myself work with a team of designers and developers and graphic artists, and what we do is we actually work on computer games that basically shows people the different types of energy. Like the project we're working on today focuses on wind energy. You want to see how it works? Yeah. Come around. Let me show you. So using wind to create energy would be good for our environment. Wouldn't you agree?
Yeah.
We're actually creating a game in this virtual world where players will be able to build their own windmill. Now we're at the point of our development process where we need to include the windmill, which is also called the turbine. You've all seen windmills before, haven't you?
Oh, yeah, totally.
Well, one of the important things is when you build a windmill, you have to understand how wind energy works. So I'm going to have you meet my friend Monica, who's going to show you all about wind energy so you can build your own windmill.
Yeah.
Meet Monica Pate Ellingson. She's a no-nonsense game designer who is going to get down to the nitty-gritty of how we harness the power of the wind.
Hi, you guys. Have you been having fun today?
Oh, yeah.
So, what kinds of things can you think of that use the wind to help them move?
Sailboats?
Yeah?
Pinwheels?
That's right. That's a good one.
Windsurfing.
That's right. Kites and windmills. That's right. That's right. So, the wind is able to help things move because it has kinetic energy, which is the energy of movement. And in order for wind turbines to actually make electricity, we have to find a good way for them to capture the wind's kinetic energy. So let me tell you a little bit about how that works. First, we have the wind. So here's our wind turbine. As the blades spin, the windmill captures the kinetic energy of the wind. Inside the turbine, we have a generator, and the rotor of the blades make the generator spin around, which makes the electricity. The generator sends electricity where it's then transformed into the electricity that you use in your homes. Okay, so are you guys ready to think like engineers today?
Yeah.
Sure.
Okay, one of the key things is wind speed. And in order to exactly figure out where you're going to locate a wind turbine, you need to think about what the wind speed is of that area. Okay, the other thing is the actual height of the tower, because you want to be able to capture the maximum amount of wind energy. The third thing is actually how the turbine is designed. The shape of the blades, how many blades, the actual position of the blades. And all of those determine how efficiently the wind turbine is going to work. Part of the engineering process, the first thing we do is we actually design on paper or through a computer program exactly what it is that we want to build. The next thing you're going to do is you're going to actually model your wind turbine using these parts right here.
When Monica dumped out all the parts, I was kind of overwhelmed because I didn't really know what to do.
And you're going to test it with this wind machine right here. All right, let's see what you come up with.
First, it's time to design the windmill. Our kids dive right into the pieces and try to build the windmill without a plan.
I really thought that maybe if we just built upward and then came in, kind of like a triangle almost, that would work.
This makes
Wait, this was going to be our...
Oh boy. Okay, we failed.
But unfortunately, it didn't.
Oh, we can do it. Come on.
But let's think of what real engineers would do.
Okay.
That's better. They decide to go back to the drawing board, taking some time to discuss and sketch out their design.
This part's all wide, and ours is all kind of like that.
Oh, I got it. I got it. Well, what if we did kind of a hexagon type thing? And we'll
And then
have
coming
one
up-
coming up from here, one coming up from here.
Oh, our connects only have 1, 2, 3, 4, 5, 6, 7, 8. It'll work.
I really like the activity of building the windmill because they can teach you something, but you won't fully know it until you actually do it.
No, we need one more green. There we go. Yeah.
All right, let's see if
Okay,
this-
we have our base.
With a true team effort, they come up with a workable design. Their windmill design uses an octagonal base for stability and a multi-level design for height. This is to reach the stronger winds higher up in the air. Now that they have the design, they have to construct the scale model.
Even though it was a little challenging, my favorite part was building the windmill because it was so much fun working together and trying to figure out something, acting like real engineers.
Oh, I know it works. Or we could just go another layer.
Another layer.
On to the testing phase. The team has to decide on the material for the blades.
It looks like it's gonna fall
Yeah, it does. It's like total like.
You wanna take this from me? So these are too heavy. There we go.
Cards were the best.
So blades mean a lot.
The direction of the blades really mattered because we had it turning one way and it kept going back and forth, not in the right direction, but then we turned it towards the wind, which really got it moving.
We had 3 models, and the first 2 did not work out so well, but our third one worked out pretty well because it was high enough for wind to hit, the blades were just long enough, and it was very stable.
Looks like it's working great. Now it's time to present the results.
Hey, you guys, your turbine looks great.
Well, thank you.
Oh, you guys did an awesome job. So what made you put the playing cards in this direction?
Well, the cards we put this way because that way the cards could capture the wind and the kinetic energy better. But if we face it more to the left, then it wouldn't capture the wind as well.
Sounds like you guys did some good testing. So did you try any other materials for your blades?
Well, actually, we didn't use any of the construction paper or the paper because it just looked really flimsy, like it wouldn't pick up the wind as much, so.
We ended up going with the cards because they were the most sturdy, flexible, and the easiest to work with.
Wow, well, it looks like you've made some great choices here. It's just awesome. Well, this is a good time to bring in our friend Andre, who is going to pretty much show you how to take your windmill model and put it into the computer game. Hey, Andre.
Hey. Meet Andre Brown. He's a 3D modeler who specializes in games. If anyone can get that windmill into the virtual world, it's Andre.
What we're going to do is today, you guys did a really good job of making a scale model windmill. We're going to do a more photorealistic windmill to go into our game.
Cool.
In 3D, it's just basic 2D points and lines in 3D space, and it makes polygons. It's all simple math. But we're going to get a little bit more detailed and more in depth in making a real windmill.
It's really big.
Yeah.
We had to go inside of it and look around and see how humongous it is.
We're looking at a 100-meter real windmill. So what we're going to do, we're going to start and build an actual wireframe. You see the points here connecting?
Yeah.
They're all simple polygons. Cool. This entire shape is made up of nothing but polygons.
Whoa.
I need some help making another blade here. You want to give me a hand, Samantha?
Yes. I had to get into the program and click around to make the polygon shapes where it would connect all the dots so that I would have a shape of my own.
Now, do I need to make another polygon?
Yeah, actually you are. You're going to connect the lines to create the shape. So just point, click, connect those two.
Oh, I got it.
There you go.
See it?
Let's add some more life to it and put some textures on it. We want to give it a sense that it's in the real world, so we have a little we've weathered the texture.
Oh, yeah.
So that's why we have a little, the scuff marks and the scrapes.
So how do you get the texture on there?
Just bring up the materials.
What surprised me the most was how you can change all the different textures for an object. Like you can have like a green or checkered or like light blue, dark blue. So that was really fun.
Let's get into the game now.
Okay.
A little adjustment to do in here. Okay, we have our windmill in the world now. Yeah. We still need to place it where we want it to be. Griffin, you want to give it a shot?
Sure. You should put it by that one spot over there. So you can, yeah.
See how easy it is to tweak it and put it in the world?
It's really not that hard.
That does it. The 3D windmill is in the virtual world, and our 3 game designers have made a lasting contribution to the game.
I thought I still heard the 4 of you still working here. How did everything go?
Everything
was
good.
really fun.
Totally fun.
Wow, looks like you guys successfully completed the game. You're officially engineers now. Way to go! Yay!
Well, they're not really officially engineers now. They should probably go to college first. They did figure out how to design, build, and test a wind turbine, and they got their feet wet in the world of 3D modeling and computer game design.
I would consider becoming a computer engineer just because I think it would be so cool to make my own world about how I would think it would be. That's pretty awesome.
I think it would be very fun being a computer engineer because I love playing computer games, and to be able to build them and kind of make them your own in a way would be even more fun.
I think computer engineering would be a fun thing to go into because I like designing things, and you get to design things in computer engineering, and you get to wear jeans to work. So that's the best part.
If you'd like to create teaching tools like this, or maybe just create your own world, maybe you can discover engineering too.